Hey, welcome back. And in example 4, we're asked what quadrants can theta lie if the sine is positive and the cosine is negative. So recall the quadrants are numbered 1, 2, 3, and 4. And the sine is defined as the ratio of y over r. The radius is always positive. So for that ratio for sine to be positive, the y value would also have to be positive. So we're looking for quadrants that have a positive y value. In quadrant 1, both x and y are positive. So quadrant 1 would be a place where sine would have to be positive. In quadrant 2, the x is negative, the y is positive, so quadrant 2 would be a place where sine has to be positive. In quadrant 3, both x and y are negative, so quadrant 3 has a negative sign. And in quadrant 4, the x is positive, the y is negative, and that negative y would mean sine is negative in quadrant 4. So sine is only positive in quadrants 1 and 2. Okay, now we're looking for the quadrants where the cosine of the angle is negative. And cosine is defined as x over r. So we're looking for the quadrants that have a negative x, and that would be quadrant 2. And quadrant 3. Both have a negative x, so those quadrants have a negative cosine. And the quadrant where both of these are true, where the sine is positive and the cosine is negative, would be in quadrant 2. Okay, so having to reason that out every time, which quadrants have a positive x, a positive y, negative x, negative y, etc., that can be very time-consuming. So this acronym, All Students Take Calculus, can help speed up this process of identifying quadrants where trig functions are positive or negative. So the A goes in quadrant 1, and that stands for all of the trig functions are positive in quadrant 1. The S is in quadrant 2, and S tells you that the sine and its reciprocal, which the reciprocal of sine is cosecant, those are positive in quadrant 2. Everything else is negative. So all are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. The T is quadrant 3. And T stands for tangent. So the tangent and its reciprocal cotangent are positive in quadrant 3. And then the C is in quadrant 4, and C stands for cosine. So the cosine and its reciprocal, which is secant, those are positive in quadrant 4, and everything else is negative. So all students take calculus. That's our acronym. A goes in quadrant 1, S goes in quadrant 2, T goes in quadrant 3, C goes in quadrant 4. A tells you that all 6 trig functions are positive in quadrant 1. S tells you that the sine and its reciprocal cosecant are positive in quadrant 2. T tells you that the tangent and its reciprocal cotangent are positive in quadrant 3, And C tells you that the cosine and its reciprocal secant are positive in quadrant 4. So in B, we're asked where is sine and tangent going to have the same sign? Are they both positive or both negative? So looking at quadrant 1, all are positive in quadrant 1. So where else would sine and tangent both have the same sign? And let's see, so sine is positive in quadrant 2, but tangent is negative, so they don't have the same sign in quadrant 2. In quadrant 3, tangent is positive, but sine is negative, so they can't both have the same sign in quadrant 3. In quadrant 4, cosine and secant are positive, which means tangent and sine are negative. So in quadrant 1, both sine and tangent are positive, so they have the same sign. And in quadrant 4, both sine and tangent are negative, and so they also have the same sign in quadrant 4. Okay, in C, cotangent and secant have opposite signs. So cotangent is the reciprocal of tangent. Secant is the reciprocal of cosine. So we're looking for a place where cosine and tangent have opposite signs. So looking at quadrant 3, that's the quadrant where tangent and cotangent are positive and everything else is negative. So quadrant 3 would be a place where cotangent and secant have opposite signs. Everything is positive in quadrant 1, so they would have the same sign there. In quadrant 2, since sine and cosecant are positive, all the rest are negative, so cotangent and secant would have the same negative sign in quadrant 2. Then in quadrant 4, cosine and secant are positive, but all the rest are are negative. So cosine and secant would be positive, but tangent and cotangent would be negative. So quadrant 4 would also be a place where cotangent and secant have opposite signs. Okay, and that brings us to the secret question for this lesson. In problem 1, you want to find the cosecant of theta when the terminal side of theta passes through the point -8, 15. And then in problem 2, the tangent of theta is equal to 3/2, and the sine of theta is negative, and you want to find the value of the secant of theta. So you're going to show your work for each problem and include that as the last page when you upload your notes to Schoology, and then type your answers into the assignment so that you can get them checked and ask questions if you need some help.